Hello, this video is going to be a review of algebra, specifically on factoring. So let's get going on the first example, hubba hubba, common term factoring. When you're doing a common term factor, what you want to do is see if there's any numbers or variables that appear in both of the terms. What I like to do is start off by making a small rectangle and putting each one of my terms in a box of the rectangle. It helps me split it up a little bit so I can see what the individual terms are. Now I want to see if there's a number that goes into both 5 and 40. And in this case, the number 5 goes into both of them. Then I want to look at the variable. In this case, we have an x squared in the first term and an x in the second term. So that means there's an x in both of those terms. Now, to figure out what the other factor is going to be, I say what times 5x gives me 5x squared? And the answer to that is just x. Then I say 5x times what is going to give me 40x? And the answer to that is 8. Since in the original problem this was a plus, that means a plus goes in between the x and the 8. Now I'm not quite done yet because I need to write this in factored form, so that's going to be 5x times x plus 8. And make sure you close the parentheses at the end of the expression. Next we're going to factor a quadratic. Quadratic is a type of trinomial, tri because it has 3 terms, but it's a special kind where you have an x squared term, an x term, and then a constant term. There are many different methods of factoring this, and you may have learned it a different way, but I'm going to show you the way that I'm going to use in class because I found it to be the most effective and the one that works the best. To start with, I'm going to make and do a diamond problem. Now really that just means I'm going to make a big X, and I have to take the first term and the last term and multiply those together, and that's going to go on top. So in this case that would be negative 8x. My middle term, negative 2x, goes on bottom. Now, what I need to do is come up with two numbers that will multiply to give me the top number and add to give me the bottom number. In this case, it's going to be negative 4x and a positive 2x. So if I take negative 4x times 2x, that gives me negative 8x. And if I take negative 4x plus 2x, that gives me negative 2x. After I do that, I'm going to construct a generic rectangle. So I'm going to take and make basically a square and put a plus sign through it to divide it into 4 equal quadrants. Then I take the very first term over here, and that always goes in the bottom. I take the last term over here, that always goes in the upper right corner. And then I'm going to take these two terms and put them in those two boxes. The order you put them in the boxes doesn't really matter. So negative 4x and 2x. Now I'm going to label the outside of my generic rectangle so that when I multiply these two terms together, it gives me the term in the box. So x times x gives me x squared. If I want to find this term, that'll be x times negative 4 will give me negative 4x, and x times 2 gives me 2x. So this is going to be one of my factors, and this is going to be the other factor. So my answer is going to look like this. X minus 4 times x plus 2, and that's going to be this quadratic in factored form. The next example we're going to do is something called the difference of squares. You can only do this when you have two terms and both those terms are perfect squares. Whenever you do this, you can start off by setting up two sets of parentheses. There will always be one plus and one minus in your set of parentheses. And then what you're going to do is you take the first term, in this case 4x squared, and you're going to do the square root of that. Sorry about that, had a little glitch with the camera there. So we're taking the square root of 4x squared, which is 2x. So that means a 2x goes here and a 2x goes here. The next thing we want to do is take the square root of 81. Notice I'm not saying a square root of a negative 81, it's just going to be the square root of 81, which is equal to 9, and that goes in both of these spots. So your final answer for the factored form here is just 2x plus 9 times 2x minus 9. Next, what we're going to do is look at a quadratic that's a little bit more difficult. In this question, or in this example, the quadratic, it does not have a leading coefficient of 1. It has a leading coefficient of 6. What I mean by that is that the number in front of the x isn't a 1, or the x squared term isn't a 1. So we started off the same way we did the other quadratic. I'm going to make my x, which is my diamond problem, and I'm going to multiply the first term and the last term, which will give me negative 18x squared. Then on bottom, I'm going to put 7x. So now I need two numbers that will multiply to give me a negative 18 and add to give me a positive 7. And that ends up being 9x and 2x. Again, I'm going to make my generic rectangle. Divide it up into 4 boxes. And then remember, the first term always goes in the lower left. The last term always goes in the upper right. And then these two terms can go in either one of these. It doesn't really matter. So I'll put 9x here and 2x here. Now, since this leading coefficient isn't a 1, I'm still going to have an x and an x for the x squared, but I need two numbers that multiply to give me 6. In this case, I'm going to use a 2 and a 3. Now, it does matter where you put them. I put the 2 here because I know that 2 times 1 is equal to 2, and 3x times 3 will give me 9. If these were switched around, I couldn't multiply 2 by a whole number to get 9, and I can't now multiply 3 by a whole number to get 2. But once I've labeled my generic rectangle, whoops, I made one small mistake here. This has to be a negative 2, which means that's a negative 2, which means that's a negative 1. Okay. I caught that mistake because I know when I multiply this number times this number, it has to equal that number in the top right. And 3 times 1 was a positive 3, not a negative 3. So then I had to go back and check my work to see where I made the mistake. So now I have my two factors, so my final answer is going to be 2x plus 3 as one factor, and 3x minus 1 is my other factor. The last example we're going to do today is a combination of common term factoring and factoring a quadratic. Whenever you look at something that needs to be factored, you always want to see if there's common terms, if there's something that goes into each one. So again, I'm going to draw my rectangle. Since there's 3 terms, I'm going to make 3 boxes. In the first box, 3x to the third. In the second box, 24x squared. And in the last box, negative 60x. So I need to say what's the biggest number that goes into each of these. So once we recognize that a 3 goes into each one of those terms, I can pull a 3 out front. There's an x in this term, an x in this term, and an x in this term, so I can pull out an x. So then I ask 3x times what gives me 3x squared, and that's just going to be x squared. I'm sorry, it gives me 3x to the third, and that's x squared. 3x times what gives me 24x squared, and that's going to be 8x. And 3x times what gives me negative 60, and that's going to be a negative 20. So then I have a factored form of 3x times x squared plus 8x minus 20. Now, I'm not done yet because now I have to see if this quadratic will factor. So again, I'm going to do my diamond problem, make my x, multiply these two numbers together, so negative 20x squared, and on bottom, 8x, because that's my middle term. And then what two numbers will multiply to negative 20x squared and add to a positive 8? That's going to be 10x and negative 2x. So now I'm going to set up my generic rectangle. And I'm going to put my first term, x squared, my last term, negative 20, and in these two spots, negative 2x and 10x. Since this is x squared, I know I have an x and an x because x times x equals x squared. X times negative 2 gives me negative 2x. X times 10 gives me 10x. So my final answer now is going to be, I can't forget about this term, so I have 3x times x plus 10 times x minus 2. And those are the examples for factoring for an algebra review.